Okay, well this is the beginning of things, really. Even though we had 5 introduction getting started videos here, now we're really moving on to the basics where we get to type inside of Xcode and play around inside this world. So go ahead and get just the basic Cocos2D template open, and you can, for now, just totally go ahead and ignore the app delegate and root view controller here. We're just going to be playing around with this Hello World class, which, if you remember me running this before, all you see is Hello World appear in the iPhone simulator. Well, if you were to go over here to your implementation file, that's the one that ends in .m, you can read through here. Well, no wonder it says Hello World, because look, there's a label, it says Hello World there. It positions it in the middle of the screen, and we've added that as a child to the layer. So it's pretty self-explanatory that that's what occurs here. It's also going to be what we wipe out in just a moment. But let me kind of emphasize that this Hello World layer.m file, which m is for implementation, is where kind of the action of things are going on. Okay, when we write code for the rest of this lesson, we're going to be doing it inside of either this init method right here, or we're going to be creating some of our own methods below that one. But again, it's where the meat of things are. And then the header file up here, as simple as possible. You can think of this as kind of a declaration of what's inside of the class, or what we're going to be doing later with it. Okay, and I don't want you guys to get, if you're not familiar with these concepts at all, don't get too into it right now. You don't need to go out and Google what is a header file, what is an implementation file. Just trust me for right now that the code that we write inside of here is going to be in the right place, and we'll go back and forth constantly throughout this entire series, putting in or declaring variable instances or writing in our method names here into these implementation and header files. But for right now, don't sweat the small stuff. And let's go over here and just get started working. Okay, so let's dump this. All right, let's go ahead and totally get rid of it. And now you would obviously see if that you ran this application, and you're not going to get Hello World inside of there. If for some weird reason you actually did still see Hello World inside of here after deleting that out, you know, it's not impossible. Occasionally you might need to go over here to product clean, and that will kind of give you well, it will definitely give you more of a fresh build on your application, and probably that would never happen in this case. But I've had it happen where I was seeing an old logo, or I mean, it's an old image or something like that, and all I had to do was just clean things up, and then it built fine the next time. So just be aware that, you know, in rare cases you do actually have to go and clean things. All right, so let's do this. We're gonna create a CCSprite, and essentially that's just gonna be an image, and it'll probably be the most commonly used thing that you play around with Cocos, because what are you looking at other than images on your phone, you know, or interacting with them to play with. So here we go. So type out CCSprite. Of course, that CC stands for Cocos, if you're curious. And then we're gonna put we're gonna make this sprite named be logo, and then to attach an image as it's the sprite's texture, we just put CCSprite and then sprite with file, and then you do the @ symbol, and then in quotes you're going to write the file name, and of course that has to have already been added to the resources, or to, well, yeah, your resources. Let's keep it simple. And then I'm going to put back the file name right there. Okay, cartoonsmart _ logo.png. And if you remember from the previous course or videos, I just literally took that file from my desktop, dumped it into the resources folder, or the PNGs folder, and it is already in there. So that's ready to go. But we've got this little warning here that says, hey, this is an unused variable. That's okay. We're going to use it in just a moment. But don't be too scared when you just are typing something out and you start seeing things like that. I'd say it's only when you kind of catch your breath after you've done 3 or 4 lines of code and you go, okay, I feel like this is going to work. And then you see a warning, you should go, maybe I'll explore what that is. But also, too, you can just go ahead and build and then see what awaits you in the output window at the end of this. Now, this is something kind of cool, and it has to do with memory. We don't have to put allocate or retain if you're used to some of the other iPhone courses. We can just let things go as they are right now. This is a CCSprite is an auto-release object, okay? So we don't have to fool with managing the memory for it ourselves. So we don't have to go down here to dealloc and release that memory. Now, something to consider there, though, is that we do need to add the child. Okay, so we need to go over here to self add child, which we're going to want to do anyway, just to be able to view the thing, and then the and then Cocos is going to retain that for us. Okay, so long as this child has been added to the layer, it's going to keep it around. All right, and something that we'll end up probably doing in a little bit is using a sprite for just one frame, okay, to determine the size of, say, an image, and then forget about it later. Okay, and that's perfectly acceptable. So, like, let's say that I didn't add it here, okay, and all I wanted to do was find out the size of this image for whatever use later on. Cocos is going to use that information, and then one frame later, okay, because it's constantly, you know, running through its frame rate, one frame later, it's like this never existed. Okay, it's auto-released it for us because it realized that we didn't use it. We're no longer using it. And if it helps you to think about this, consider, if you're coming from a Flash background, consider if you had, let's say, a movie clip, right, on stage here. This is a movie clip. You've called it box, right, and you've got some code over here on this frame that's, you know, box.x equals whatever the value is, okay? And then you got rid of the box on the next frame, okay? But you still had some code up here, or some action script up here that was referencing that box. Well, the code can't find the box anymore, so it's gone, all right? And in Cocos' case, it would crash if that happened, but you know what? You don't really have to worry about that happening too often, because generally you're going to be just adding your children on this stage, and they're going to be sticking around until you know that you've gotten rid of them. And you're usually going to get rid of them yourself by doing something like remove child. So, yeah, there we go. Did that seem kind of simple? And you know what? If you do want to see right away, you can get rid of yourself, remove child, and you can specify the child. Ooh, well, actually, that was reorder child. Sorry. Self remove child, and then that would be the logo, and then cleanup. We would put no right here, but you would possibly specify yes inside there if you knew that this child had its own kind of methods running inside of there, and we'll talk about that later. But for right now, this you're okay with cleanup as no. And you might have noticed that when we started typing self, or actually let me back it all the way up a little bit here. Self add child, and back it up even further. If you hit the escape key, it'll give you your hints for what you could possibly put in here after add child, and that node refers to. A node's kind of your generic object here, so it could be a sprite, it could be a layer, it could be a scene. In this case, we're just dealing with sprites. So again, we're going to put out here logo, and then it should still prompt us if we hit escape again to add in some of these other options, and we could put in our z depth, okay? And this is arranged from it's a negative number, or it could be a positive number, okay? Let's just go with a z depth of 1, okay? And visually, if something was at 2, that would be above something at 1, okay? And obviously, something in a negative number would be visually lower than or underneath our logo. And then to keep this going, we can add a tag in here, and this could be 1, 2, 3, 4, 5. Okay. And we'll talk about identifying things by our tag in just a little bit, but let's go ahead and run this. So make sure everything's working, and hey, sure enough, there it is. But this might seem kind of odd to you. The image is centered around this 0, 0 point, and the odd thing might be that it's 0, 0 is in the bottom left. Well, just gotta get used to that. I've gotten used to it, and I kind of like it now. But you know, if you think about things going up, you know, higher up in value than going up like a slope, I don't know. Let's go ahead and put this into the center of the screen. So we'll just quit that out, and we're gonna write logo dot position, and we could put CG point make. All right, so it wants two values here, our X and our Y location. And you know what, we know that 480 is the screen resolution of the iPhone. Divide that by 2, and then 320 is the height, at least if it's in landscape mode like that. So we'll divide that by 2. Of course, if you're thinking ahead, we'll probably undo that in just a moment, but that should go ahead and put that right into the middle of the screen. And hey, look, there it is. Okay, so let's make things a little bit more resolution independent. So if this was a universal app, what you would probably want to do then is make it so that we know the size of the screen. Okay, so we're going to put CG size, and there's an easy way to find this out. Just go over here, write CC director, shared director, and that too is something we'll talk about more at a later date, but basically this is just going to give us the window size in a CG struct, or just a struct right here. So we'll be able to access size.width and size.height down here. So we'll divide size.width by 2, and then size.height by 2. And if we run it again, we'll get the same exact location for that image. But you know, if this was the iPhone 4, and for some kind of odd reason, the simulator doesn't, even though it says hardware device iPhone Retina, when you query the surface size doing that, you don't get back 960 by, what's 380 times 2? 7, I don't know. 6 something, right? 320, yeah, 640. You don't, here, let's just run it again. You don't actually get that. You get this giant iPad size screen, and then it still says over here 480 by 320, so it's kind of pointless to check things out. But if you, I'm like 98% positive that if you were playing around with your iPhone 4 and you did this and you queried the size, or you got the surface size down here, that spits it out automatically. You get that whatever, 960 by 640. I gotta remember those numbers. So anyway, and then of course too for the iPad, if you test it over here, it's gonna be 1024 by 768, and divide this by 2. No matter what, you still end up in the middle of the screen. Okay, so let's move on down here to right logo. That rotation. This is nice. You can just write 90 after this. You don't have to convert any sort of like degrees to radians or radians degrees or anything like that. So if we just wanted to rotate this guy 90 degrees, hey, sure enough, oh, let's get this back to iPhone device. iPhone, there we go. So 180 would make this totally flipped upside down, but let's go ahead and leave that at 0 and keep running through here. So logo dot scale, this is another one we can mess with. 1 is what it currently is at, so you can imagine that 0.5 would give us a logo that is half-sized. And there we go. And then you can keep going with that. 2 would be double. All right, so let's just make that 1 though. And then you can go with logo.scale X, and this would make it squashed halfway through, halfway along the horizontal width. So again, kind of an easy one. Very similar to Flash there too. Scale Y, that's going to do the same thing. You've also got this option of flip X, and this is a Boolean value, so that means just it's yes or no. So let me just type these guys out so you have reference for them. And pretty sure that the this is just affecting the image, okay? Whereas if you were to scale the X to be like -1, which would actually flip it around, pretty sure that would take along with it any other children of this sprite, and you can add more children to this. So again, that's very similar to Flash, where you could have like a movie clip and then add children to that movie clip. Kind of like how the logo looks in reverse like that. Okay, so keep going on. Let's add a few more. Logo.visible. Wait, yes, we want that to be visible, of course. You can go with logo.opacity as well, so you can make this. Well, the high range here is 255, and let me just put range is 0 to 255. Oops. Okay. So 130 would be about halfway. Yep, sure enough. Okay, set that back. And now let's play around a little bit by getting the child by its tag. All right, so if we're not sure, well, no, I don't want to write that way. Well, just an alternative way to access your sprite would be to write self, get child by tag, and then there's our tag right there, 1, 2, 3, 4, 5. That's what we put in before. And in some cases, you can just put a dot after this and, for example, access the scale property this way. So we can make it double the scale. For certain things like opacity, you can't do that. But for a few of them, you can. Hey, look at that thing. Huge. But this is very, very useful, and we're going to talk about it quite a bit later on. But I don't think what's useful is putting in some crazy tag number like that, which you're probably going to want to do, especially if you have a pretty complex game and you do want to identify things by their tag number. Often is set up a constant definition for this tag. So tag for logo would be a good name for it. All right. And let's go over here to File, and then New, File, and under, over here, let's just create an empty file, call it constants.h, save it, and then we will define, so we're just going to write define tag for logo. And then you can put in here any unique number you want. You don't have to follow it up with a colon sign. Go ahead and save the file. Come back over here to Hello World. And then you do want to write in import constants.h. So it's going to import that code into that. So now if we come down here and replace tag for, or replace that number with tag for logo. It should turn tinted brown like that. That's a good sign that things are working. And then sure enough, let's try that again. And boom. Okay. You might be wondering, why would you do that if you can just write logo right there? Well, let's suppose we had a different method. Okay, so let's just say, let's just call this another method. All right, so we could call this method out right here, we'd say self another method, and that will call the code that is inside of there. Okay, and it'll give us this little warning here for well, until we do this. Let me go ahead and copy this and just declare it out here. Okay. All right, no longer giving us that warning. What I just did there kind of gets into something else, but let me just keep going through with this train of thought. All right, so what if we wrote inside this method a logo dot scale equals 2? Now it's going to tell us, now it's going to give us a real warning. It doesn't like that at all because it has no idea what we're talking about here. It's going, what is this logo that you keep referring to? Okay, so here is a case where we would go and take that off, paste it in there, and sure enough, it's got no problem. Okay, it's going to just go, hey, all right, I'll go find that guy for you. Don't know his name, I'll go find him. It's kind of like he's got an ID tag on, you know. And then you've got absolutely no problems. And let's see if I'm correct about that we don't have any problems. Okay, sure enough, that does work. All right, now what happened over here? Basically was just saying that I might not be able to respond to this method that you're talking about here, okay? And all it wanted for us to do was to just copy the dash void part. Okay, void just means that we're not returning anything from this. And then take the method name, go over here to our header file, just paste it on in there. So really it's just that first line, just without this part of it, okay? And then you're all good at that point. And why are you doing that? Well, this would give another class access to this method as well. It also kind of tells, you know, you, the developer, what this class does, that, hey, you know what, look at that. There's a method in here that does XYZ, okay? And, you know, it's not, well, it's not easy to kind of see why you would do that here with such a simple file, but let's do this. Let's go ahead and I've unfolded all the classes here for Cocos2D, and let's go find maybe the one for Sprite and see what is inside of its header file. So you could go down here, and here we go, we'll start at the top. But they've got their methods listed down, and sure enough, they've got them all explained in there, as a good coder should, right? And then you can just kind of go and read through and see what that class does, okay? And you don't have to actually go into the implementation file and find all those same things, okay, and read through all that extra code. But you can go and see, all right, well, this class has a method that says a knit with file, a knit with image, a knit with, you know, and so on like that. So anyway, it kind of makes things maybe a little bit more complex, but there you go. So back to this, back to the lecture at hand. We've now hopefully shown you guys a little bit more about why you'd use that tag for logo. And then alternatively though too, you could go over here to your header file and just specify that I'm going to use a sprite called logo often throughout this project. So I don't want to have to mess with doing that. And then in that case, you would just take out that part right there, okay? You won't have any problems. It doesn't make this wrong anymore, but then you can write logo.opacity equals 130, right? So in this case, since we've declared it out here in our header file, okay, that works again, all right? At least I'm pretty sure. Let's go ahead and run it just to test it one more time. Hey, look at that. That looks half transparent to me. And, you know, I think as the course progresses, we're just going to kind of naturally figure out when the best usage of just having something be identified by its ID tag and versus declaring it out here in the header file. You know, I think in generally the rule there will probably just be how often we're going to be using it. Okay, logo, if it's going to be there the entire game and we're constantly going to be going back and changing something about it, then yeah, that probably is going to be the best usage for it. Certainly like your main player sprite, that would be another case. But if it was just some sort of message to the person playing that said something like new high score achieved and it was going to stay up there for 10 seconds, then in that case you might want to just ID it by the tag, okay, and then have a method later that removes the object by that tag, okay. So it's that way it'll get created again when necessary and then removed when necessary, and it's not using any sort of memory throughout the game, or you know, if there is that much of memory hit. I'm not even sure exactly, but again, we'll figure that out as we go along, but let's continue doing what we're doing. And I would like to, just as an example here, throw in another sprite, and we're going to call this new app image, okay, and you'll see what I mean in just a moment, why I'm calling it that. CCSprite, sprite with file, and again, we put in the name of it, .png. Currently, there's no file named that in this project, so let me move this out of the way for a moment. I just have this on the desktop right here. Just going to drop it into the PNGs folder, copy items. Yep, we want to do that because it's not already in the resources folder or the project folder, and it's just telling me that it's not actually in use. Now, instead of adding it to self, which you just put on the layer, we're going to put it inside of the logo. So add child, new app image, put this at a Z depth of just 1 by default, tag. In this case, let's go ahead and just keep kind of using these tags for the heck of it. I'll call that other tag. And then let's go over here to constants, and we'll define our other tag as, I don't know, how about 5, 4, 3, 2, 1. They could be just as simple as 1, 2, or 3. It doesn't, you know, just coming up with kind of arbitrary numbers there. And sure enough, there we go. That's working okay. And then let's test this out just to make sure it does end up dropped in there. We'll probably have to change the position in just a moment, but I think we should see it. Come on now. Oh, shoot. You know what? Let's set this tag, that back, and then. Sorry. Okay, there it is. It is showing up at 0, 0. It's just an image that says new app. And let's do this. Let's make it so that over time we will move our logo off to the right, and then it'll bring along with it the child that's been added to it. But just to test it out for just a moment, make sure it actually has been kind of added in there. Let's go and set the logo dot position equal to, and let's see, go CG point make. We can use logo dot position dot x, and then let's just add about 100 to it, or 200 to it, and then logo dot position dot y. So it's taking its existing position and it's going to shift it over just 200 pixels. And yep, sure enough, it dragged along that with it, because again, you can think of that image as being stored inside of the existing sprite. Okay, and let's get to that for right now. Actually, I'll leave it because we'll steal that line in just a moment. We are going to talk about scheduling a selector. Okay, so let's come down here. Actually, let's just go ahead and comment this out, so we're not using it. You don't get points taken off for having methods in here that aren't in use. It's things like variables or sprites, whatever, that they're telling you, hey, you're not using that thing. But if you just have a method that you're not using, you're not gonna get a warning about not using it. Okay, so now let's come down here and we're gonna write self schedule, and then we write here is the @ symbol, selector, so we're specifying that it's a selector here, and we are going to write update logo. I do need to follow this up with a colon, all right, and then interval, and it's going to want a time from us. Okay, so how often is this going to be updating? If I put in here 1.0f, that's going to be updating every second, but just once a second. All right, now if I divided that by 60.0f, f stands for float, just a floating point number, then that's going to be going pretty quick, because it's updating 60 frames per second. Okay, 1 divided by 60, and let's just put a little note here that says, so this will update 60 frames per second. And I would say most games probably do update at 60 frames per second, or maybe 30 frames per second. It just depends on how intense they are. The pinball games I made recently, they're all updating at 60 frames per second. Okay, so now we need to actually write this method here. So let's write void. We're not returning anything from that. And if that doesn't, what I just said there doesn't make sense to you yet, it eventually will, because we'll undoubtedly write a method eventually that will return something. Okay, so what it wants from us though is the CC time, and then we'll just put in here that our delta for the time that we're passing to it. Okay, so this is just that interval. All right, and we now get to put something inside of this method that will move along our logo quite often. So let's just copy what we've already got here. Or actually, I'll just cut it, paste that in there, and let's just add 1 to it, and let's see what happens. Hey, look at that. We're not going to be seeing you much longer because there's nothing in there that tells you to stop. Let's close that out. One thing we haven't talked about yet is putting in cc log. Oops, cc log. As a log statement, and we can put in here our method is running. And if we do that, we're going to get in this output window a lot of those messages that say our method is running, and I forgot to put in caps the OG part. There we go. I knew they didn't look right. Okay, and sure enough, look at that, it's going by pretty quick. And the reason I'm putting a log statement in here, I am fairly confident it's running already because it's moving that, is I want to see when this stops running, because we're going to put an if statement in here that basically destroys this scheduler at a certain point. And, you know, we could create a variable that just ticks up to a certain point. Maybe the variable starts at 0 and then at 300 runs an if statement, or at 300 stops the scheduler. Instead, let's do this. Let's try just writing logo.position.x. Once this is greater than, or you can do equals 400, in that case, then we'll stop updating our logo, or just kill our method. And to do that, we just get to write self and then unschedule. And there's this nice little quick reference for the currently running method, and that is to just write in there _cmd and finish that off with a semicolon. And sure enough, we should not be getting any error messages at that point. So let's see what happens. And again, look at that, it is dragging along our little new app image with it. And sure enough, it stops. And also, of note is it's no longer spitting out that our method is running. So we at least know that that got killed. And you could do, you know, if you really want to be finicky about, you know, sending messages to the output window to really tell you what's going on, let's say unscheduling the current method. And, you know, if you just want to get kind of clever with things, you could also put in here, oh no, put in here logo, get child by tag, other tag, dot position equals, you know, there's another way of doing the same thing, writing CG point make with Cocos. You can write just CCP. Oops, CCP. How easy is that? Gives you the same thing, just a struct that contains an X or Y value. And in this case now, we would just write logo, get child by tag, other tag, dot position dot X plus 5. We'll add 5 pixels to it. And then we can put in here the same thing, position dot Y, so that just stays the same. And now, let's see if I can squeeze this out a little bit so you guys can get it all. Oh, just barely. I believe that code's correct. Let's try and run it and see what happens. Yep, there we go. So, it's kind of a weird way of writing this, but I'm just kind of trying to prove that, you know, in this case we identified our logo and then the tag with, or the child within it, with that tag. If we tried to write self dot get child by tag, other tag, I don't think anything's going to happen here because it's not going to find it. I don't think it's going to crash though. No, sure enough, it's not. It's still just dragging along this image with it, but obviously it's not moving forward like that. And that's one of those cases where I feel like that Cocos is a very forgiving language. It didn't crash on us, you know, when it couldn't find that. Oftentimes, if you do try to make reference to something that doesn't exist, it'll tell you in the output window that that child wasn't found. Usually it's when you try to remove a child like that, that says, I can't find it, and just kind of ignores it like that. So, again, very forgiving. I like that. Of course, you don't generally want to, you know, be making mistakes like that, but there you go. But like I was saying, this is an eyeful right here, and it's kind of unnecessary because what we could do is, if we were still insistent on not declaring our other tag as part of our in our header file, we can go and cast another sprite as that that same sprite. Okay, so just bear with me here as I type this out. Here we go. We're going to write, well, let me first give you an example of why you'd want to do that. Okay, so I'm going to paste this down here, and let's suppose I want to change the opacity as well. Well, you'll notice first off that there's no completions there. Well, if I were to write minus equals 1, that would take from the opacity, you know, incrementally just 1 every time this ran through. But the error here says property opacity not found on object of type CC node. Okay, so it just is telling me that, well, I don't know what this is exactly. You know, it's a child. I know that. Maybe it's a node. Maybe it's a layer. Maybe it's a scene. Maybe it's a sprite. But so I'm not going to assume anything, and I don't think opacity is something you could access with it. All right. So what we basically have to tell the compiler here is that, well, we know that that's a sprite, and we can access the opacity for it. So let's go about doing that. So we're going to come over here and let's leave that there for a moment. We're going to write CCSprite, and then I'll just give it the same name it had before, although even though it doesn't really, well, let's write new app image too, so there's a bit of a difference in y'all's minds. And you would think you could just write this, and you are getting close there, okay? What we actually need to do is specify that it is going to be a sprite, okay? So we're confident. We're saying, yep, calling our shot there. That is going to be a sprite, okay? And then from that point, you can just use appimage2 like that. Now, keep in mind that this is actually the same sprite as before, not a new one. Okay. And now, I believe if we were to run this, it is very important to note that that is not a new one. We don't have to add it to anything. We're just basically making a new reference to it there. And sure enough, it is fading out. If we were to make this be 2 instead, I think, there we go. Slowing down a little bit. Now what happens if the opacity goes below 0? I thought this might actually crash it, but it's kind of interesting. What it does is it'll go back to 255 again, so it'll give you that weird kind of like flickering effect. And this is a nice little short way of writing exactly this same line right here. If we were to put opacity equals itself minus 5, okay, and that same little trick works with multiplication, with addition. So just a nice little short way of writing things. And you know what, since we went ahead and did this, let's go ahead and come up this way. We'll put that up there, and then we could rewrite this entire line as something a bit shorter. Let's just comment it out for now, so you guys at least still have it to look at, and then, oops. And let me put a little note here that says, same as the line above. And I could do that same thing over here too. And let's just run it, make sure that is the case. There you go. And you know, for good measure, let me do this. Let's make this not based on the position. Let's go ahead and put a variable in there. So we'll go over to our header file, and this can be an int type variable, so it's just an integer, and we'll just call this counter. All right. We don't assign any value to it there, and we don't have to hold this guy in memory. All right, it's just an integer. So we'll just dive right over here, and then before we run or schedule our selector, we'll just write counter equals 0, and then we can put counter plus equals 1. Okay, so adds 1 to counter every iteration, or I should say every update. And you might also want to do this. I'll put this down this way. Let's find out what counter is. Counter is and you'd think it would be something like repeat the variable there. Nope, what you do is you put that percentage sign, drop an I in there, and this will get replaced with the value of counter, okay? And then we'll just take this, if counter equals, we need to do double equal signs there. I mean, as a kind of safety, you could do if it is ever greater than or equal to 400. It's still going to stop this same place as soon as it hits 400. But yeah, just let me throw the double equal signs in there just so you guys at least have that early on if you're not used to programming. And now let's see what happens. Let me clean this up a little bit though, get some spaces in here. Oh, there's our counter. And goodbye. Obviously that ran a little bit longer. Let's make this be 300, and let's start the initial position here at start at 0. It's like a cheesy commercial. And yeah, sure enough, it stops kind of close over there to the middle of the stage. Now let's think what else we could possibly talk about here. Well, let me show you guys the code to unschedule a command if it's if you're not just killing the currently running method there. And this would be unschedule, and then we just put in here, actually you can just copy out this part, add selector, update logo, and of course you would want to just run one of these and then unschedule it right away, but just as an example, that's how you would get rid of that guy. So let's just comment that out, and don't forget to throw in that colon afterwards. It does require that in there. And then let's do another thing. Have we actually gone over removing children? Well, if not, let's say when this counter got up to 300, you want to actually just get rid of the child. So you could go to self, and as soon as you start typing remove, like so, you get some hints there. Remove from parent, remove child by tag, or just remove child. Let's just go with or remove all children. Let's just go with remove child, and in this case all we're getting rid of is our logo. And clean up. We don't actually need to clean up anything because there's nothing in that child that's like a scheduled select or anything like that. So now if we were to run this, let's go. I actually crashed a little bit ago, so I might have just run a clean build there and took a little bit longer. And gone. And then of course too, if you want to just get rid of a new app image, just don't forget that you'd be writing a logo inside of here, and then remove child, and then that one. Another thing you could do too is just dump everybody off the entire layer too as well. So you could do remove all children with cleanup, no, and boom, 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 everybody would be gone. Let's go ahead and just comment this out. And obviously, as you saw, when we removed the logo, it got rid of any children inside of it. Okay, so it got rid of that new app image too, because remember that one is tucked nicely inside of there. By the way, one thing I did, and I should have probably mentioned a while ago, is for this source image here, I made this a power of 2, meaning the dimensions for this are either 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, or you can even go with 2048. This image, I believe, is 512 by 256, and you don't have to make your images in those dimensions, but they do take up less memory if you do. And that was actually something I didn't discover until recently when I was going back over one of my books. And yeah, I kind of wish I'd known that before, because to go through the existing games that I have and change all the image sizes, it would be kind of a pain. Now, keep in mind, I would just be kind of adding, in most cases, extra canvas space to it. But by the way, did I show you guys how to get the bounding box size of things? Maybe I did not. And you know, we could do a CC log with that too. So after we've got our image on here, you could write CC log. We can put bounding box size of image is, and let's do width. I'll make that a float. Float or int would be fine there, so either %F or %I believe. And then height. By the way, too, if you're running these CC log statements, you don't have a space here, it's actually not going to cause you any problems. You don't have to have a space. Okay. And then, so we're going to go with logo dot bounding dot you don't, I think that's correct. My notes on this are not actually right in front of me. I might have to put size in front of that. Let's find out though. It's got a problem with it, obviously. So let's see. Maybe size. Oh, there we go. Everything turned a different color, so that's a good sign. And let's quit out of that. What we want to see is in the output window up here. And bounding box size is, sure enough, 512 and a height of 256. Alternatively, you can get the content size too. So here you go. So that would be your source image, whereas keep in mind your bounding box size could have been scaled down after the fact. And let's see, it looks like there we go. Just had to take out size there, and sure enough, let's, oh, I lost it. And obviously, yeah, those are the same at that point in time. But if we were to move this down here and then scale this down to 0.5, let's see what happens then. Oh, you know what? Shoot. Because I left these scales up. I'd have to do them all. Okay. Let me just test this, then I swear we'll move on to something else. Okay, so sure enough, that time around, I got the bounding box size is 256, and then the height is 128. But even if I run this line after this one here, it's still going to go back and look at my original content size for that image. Okay, so that's kind of why there's two different lines of code for that. Alrighty, and yeah, so let's, I guess well, I think I've got enough notes in here, but if you want a little quick review, I think some of the most important things that we did in here were just, if you've never seen how to create a method, okay, so just a bunch of code inside of a method, and you know, essentially this is the same thing as running all that same code right down here, but it's a nice way to organize your code. And of course, if you're writing a really complex game, you're gonna have lots of different methods for doing different things, and two, it saves you time, because a lot of in a lot of games you do the same thing over and over again in different places, like let's say resetting the score. Okay, you might call that method from 5 different places, so instead of having that same code written 5 different times, you just write it in one place and then you call the method. And then of course too, we saw the almighty way to schedule a selector here at a specific time rate, and that is of course very useful in just about every game you can possibly think of, because when is time not occurring? And then and keep in mind too, this was again 60 frames per second. If I had just wanted to make this, let's say 10.0 f, that would be every 10 seconds. Okay, so it goes pretty slow real quick if you just don't divide 1 by 60. And then we got ourselves let's see, counter in here, so that was something that we declared out here in our interface. And what else? Well, and of importance, I guess, we don't actually have to deallocate anything. There was nothing in here that we allocated, okay? All these objects that we use, the CCSprite, they were auto-release objects, so we don't have to worry about the memory management there, and we don't have to deallocate things like these numbers. They're not objects, okay? It's just an integer. And when we do come into some things that we need to deallocate, I will, of course, do my best to remember that we got to do that. Okay, so I think it's time to get on to the next video where we get to explore something totally new.